Now let's start with the third question again. If a, b, c is equal to 1 and a, b, c, they are not equal to each other and they cannot be 0, so prove that 1 over a times a minus b times a minus c plus 1 over b times b minus a times b minus c plus 1 over c times c minus a times c minus b is equal to 1. Let's start now. As you see here, we have some similar expressions, similar terms, like a minus b, b minus a minus c, c minus a, and b minus c, c minus b. If we'll change their places, what we'll get? Let's see, a minus b times 1 over a times a minus b times a minus c, plus, here I will change their places, so it will become b times, we'll take the minus in front, and I will have a minus b, and 1 minus here, and it will be c minus b, plus, here we'll have 1 over c times, here I will take the minus minus a minus c times c minus b will have is equal to. Now as you see here, I have minus times minus, which will be plus, and here 1 minus, I will take it here, so we'll get 1 over a times a minus b, a minus c, plus 1 over b times a minus b, c minus b, minus, plus times minus will be minus, 1 over c times a minus c, c minus b is equal to. Now as you see, we have the same terms. I can equalize the denominator easily now. I will multiply this one by bc, c minus b, this one by ac, a minus c, and this one by ab, a minus b, and then we'll get from here bc, c minus b, plus ac, a minus c, minus ab, a minus b, over abc, a minus b times a minus c times c minus b. Now if we multiply them one by one, we'll get bc square minus b square c, sorry, it's not square, b square c, plus a square c minus ac square, minus a square b plus ab square, over abc, a minus b, a minus c, c minus b. Now if I will take some common terms in front of the parentheses, I will get, look, b square, I will get b square in front of the parentheses, and it will become a minus c, these two. Then I will get ac from here, and I will have a minus c again, and minus b from these two terms, and I will find a square minus c square. over ABC ABC times A minus B times A minus C, C minus B. Now here, as you see, we have A minus C in common, so it will become A minus C times B squared plus AC minus B times, so here I will have A plus C over ABC A minus B times A minus C, C minus B. Now if I will multiply this one by one, I will get A minus C times B squared plus AC minus AB minus BC over ABC times A minus B, A minus C, C minus B. Now here again we have some common terms. It will be A minus C times, here if I will take minus B in front of the parenthesis, I will get C minus B, and here if I will take A as common term, I will find again C minus B over ABC times A minus B, A minus C, C minus B. Now we have CB in common, so we'll have A minus C times C minus B times, as you see, A minus B over ABC, A minus B, A minus C, C minus B. So I can, because in the question, in the beginning, it's given that A cannot be equal to B and B cannot be equal to C. So here I can do some simplifications. A minus C with A minus C, A minus B with A minus B, C minus B with C minus B. So at the end we'll have 1 over ABC, and it's given that ABC is equal to 1. So 1 over 1 is equal to 1. So this is the end of the question. We needed to prove that this expression is equal to 1, and we proved it. Now let's continue with the fourth one. Now here the question is, if the numbers x, y, and z satisfies the conditions x plus y plus z is equal to 1, x squared plus y squared plus z squared is equal to 1, and x cubed plus y cubed plus z cubed is equal to 1, then prove that x, y, z is equal to 0, it says. I will start with the first equation. X plus y plus z is equal to 1. I will take the square of both sides. X plus y plus z squared is equal to 1 square. So this is x squared plus y squared plus z squared plus 2xy plus yz plus xz is equal to 1. We know from the question it's given that x squared plus y squared plus z squared, it is 1. So it means that from here we are finding that xy plus yz plus x z is equal to 0. Let's name this one as the first equation. Now, if we'll multiply the first equation and the second equation, what we'll get? X plus y plus z times x squared plus y squared plus z squared is equal to 1 times 1, which is 1. Now, if I will multiply them one by one, I will get x cubed plus xy squared plus xz squared plus yx squared plus y cubed plus yz squared plus zx squared plus zy squared plus z cubed is equal to 1. Now from here I have x cubed plus y cubed plus z cubed plus xy squared plus yx squared plus xz squared plus zx squared xz squared zx squared y z squared plus zy squared is equal to 1. Again, we know that x cubed plus y cubed plus z cubed is equal to 1. Plus here I have xy in common, so it will become y plus x. Here xz in common, so z plus x I have, plus yz times z plus y is equal to 1. This one and this one will go. And let's write xy yx plus xz times z plus x plus yz times z plus y is equal to 0. Let's say that this is second equation. From the given, from x plus y plus z is equal to 1, I can find from here that x plus y is equal to 1 minus z. In the same way, I will find y plus z that it is equal to 1 minus x, and what I need, z plus y is equal to, we wrote y plus z, sorry, z plus y, not x plus z. X plus z is equal to 1 minus y. If I will write in the second equation, I will get xy times 1 minus z plus xz times 1 minus y plus yz times 1 minus x is equal to 0. xy times minus xyz plus xz minus xyz plus yz minus xyz is equal to 0. It will be, I have here xy plus xz plus yz minus 3xyz is equal to 0. From first equation, we found here, if you remember, from first equation we found that xy plus yz plus xz is equal to 0. So this one is 0 from first equation. Then I will have minus 3xyz is equal to 0. So from here we will see that x, y, z is equal to 0. Question was to prove that x, y, z is equal to